Okay, 30 here. Conductivity of glass. Materials conduct heat. Matters when designing houses. Conductivity is measured in watts of heat power transmitted per square meter of surface per degree Celsius of temperature difference on the two sides of the material. In these units, glass has a conductivity of 1. The National Institute provides data on properties of metals. Here are 11 measurements of heat conductivity of a particular type of glass. Oh, properties of materials, not metals, sorry. Okay, so here's a sample on different um, measurements of different types of glass. We can consider this a simple random sample of all specimens of glass of this type. We want to know, okay, so if we can do it, we're going to want to do a confidence interval on this. So my conditions, if you watched the videos before, we've been talking about this. 1, the sample has to be a simple random sample. 2, the data has to be independent of each other. Okay, in other words, one measurement can't affect the other. Okay, which we're good with that. And 3, the sample is large, which this is not, so that doesn't make it. Or the sample is, we say, unimodal. Make this bigger, and symmetric. Well, another way of saying unimodal and symmetric is we say nearly normal. Okay, and that's what they're saying. Is there a sign of deviation from normality for our sample? Because if our sample is nearly normal, then the population is nearly normal, then the sample distribution is nearly normal. Okay, does that make sense? Sample nearly normal implies the population nearly normal implies the sample distribution nearly normal. And this is what we need, is a sampling distribution to be nearly normal to do this. Okay, so how do we do that? Well, we've got to graph those and go from there. So let's see, they said to make a stem plot. I'm going to do something different on here, and just to show you, because I want to use my calculator. Okay, maybe not. Get on their calculator. Okay, here we go. So I'm going to put the data in my list. Clear that guy. 1.7. The reason I'm putting it on my calculator is because a stem plot is hard yet to make by hand, and I can make other plots on my calculator and to see if it differs from normality, or to see if it's roughly unimodal and symmetric. Basically no big outliers is what we're looking for. And so I'm going to look at this, and the easiest one to make is a box plot. So let's make a box plot and see what that looks like. Okay. And I'm going to go zoom stat, because that's just going to put it in a nice thing here. Okay. And see, here's my tail on this side. This side doesn't have a tail because I don't really have that much data. It's not really perfectly symmetric, but I don't have it's not too far off. I don't have, a big long tail on one side. It doesn't go like this. with a big long tail or, kind of thing like that where it's really skewed. It's just, a little bit off like that, something like that. So that's relatively close. And with that many pieces of data, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data, that's close enough. Okay. So 95% confidence interval is going to be stat tests t interval. Oops. We're going to do it 95% confidence interval. Oh, no, I'm sorry. We're doing data. What am I thinking? It is late. And 95 L1, 95% confidence interval. Calculate. So it's going to be x bar plus or minus t star s over square root of n. And so it's going to be 1.09, 1.15. 1.09, oops, 1.15. Okay, so I'm 95% confident the mean conductivity of this type of glass lies in this interval. Okay, does that make sense? Hope so. And you know what? Let's go to the last problem. 735. Genetic engineering for cancer treatment. Here's a new idea for treating advanced melanomas, most serious kind of skin cancer. Genetically engineer white blood cells to recognize and destroy cancer cells and infuse them into patients. There were 11 patients whose melanoma had not responded to existing treatments. The question is how rapidly the new cells would multiply after infusion, as measured by the doubling time in days. So here's the doubling times. Okay, now this is in days. So 1.4 days, 1 day, etc. Is it reasonable to use the T procedures? So in other words, are there any outliers in this data? Okay, does it look like it's relatively unimodal and symmetric like we just did in the very last problem? And since I'm going to make a 90% confidence interval, we're going to need to put the data in here. So let's go ahead and just put it in right now. And then look at the graph. 1.4 or a box plot. Good practice. 1, 1.3, 1, 1.3, 2, 0.6, 0.8, 0.7, 0.9, 1.9. Okay, so I'm going to go to stat plot. And we're going to do box plot. It's all set up. So we're going to go zoom, stat. I guess zoom 9. Enter. Okay, so there it is. So it's slightly stretched out to the right, but not enough to worry about. So as long as it's close is all we're worried about. So is it reasonable to use? Yes. No outliers. Roughly symmetric. Okay, only slightly pulled to one side. Okay, give a 90% confidence interval, so that's going to be right over here, x bar plus or minus t star s over square root of n. And so that's going to be my t interval. Data L1, 90% though. Oops. 0.90. It's not touchscreen, calculate. 0.92 to 1.4. 0.92 to 1.4. So what that says is I'm 90% confident the true average doubling number of days um, to double, right? Is between 0.92 and 1.4 days to double what? To double your cells, the new cells. Okay, so I'm 90% confident the true average number of days to double the new cells is between 0.92 and 1.4 days, right? Okay, are you willing to use this interval to make inference about the mean doubling time in a population of similar patients? So in other words, are you willing to generalize this? Um, what do you think? Uh, there's only 11 patients, similar to similar patients. What do you think? I don't really see a reason not to, other than the fact that it's a small sample. I'd like to see another sample. I'd probably, in real life, they would probably use a repeat this, several times before they started saying, "Hey, this really does work," because it is a small sample. But other than that, looks like it's promising. Okay, there you go.